Okay, I just want to make a small correction to the video I just made on graphing quadratic functions, and that's about the intercepts. I'd written down the equation incorrectly the second time when I was trying to calculate, and I came up with intercepts that were positive or negative radical 5, which estimated to positive or negative 2.2, but that's not where the graph looked like they fell. And that's because I wrote down the equation incorrectly. So the equation we used, oops, get back to black, sorry, or was supposed to use, was y equals 5 minus 2x squared. So on this one, again, we're going to let y equal 0. So 5 minus 2x squared equals 0. We're going to subtract 5 from both sides. We get negative 2x squared equals negative 5. Divide both sides by negative 2, and we get x squared equals positive 5 halves. So when I take the square root of both sides, I'm going to end up, don't forget when you take the square root of a variable, you have to write plus or minus. And then we're going to get x is equal to plus or minus, and then we're going to have to work with this radical 5 over radical 2. So we're going to rationalize the denominator by multiplying by top and bottom by radical 2. And we get x is plus or minus radical 10 over 2. So what we're going to estimate is what does radical 10 equal. So it falls between 9 and 16 for perfect squares. Their square roots would be 3 and 4. So it's somewhere between 3 and 4, much closer to the 3. So what we're going to get is 3, let's see, let's try things like 3.2. So we get 4, 6, placeholder 6, 9, which gives me 4, 12, 10. So 10.4. That's too high. So let's try 3.1. So we get 1, 3, placeholder 3, 9, and we get 9.61. So this one is going to have a difference of 0.24, and this one, the 9.61, has a difference of 0.39. So it is a little closer to 3.2. So it'd be something like 3.17. So let's use the 3.2. So this would be equal to plus or minus 3.2 over 2, which would give us plus or minus 2 goes into 3 once, with 1 left over and into that 6 times. And that's almost exactly what you see in that graph. So sorry for that error. All right, good luck. Thanks.